Okay, so we are still on section 4.3. So there's a couple more things that we should cover. So first of all, we have the second derivative test. So this is 4.3. Oh, just switch to blue. This is part 2. And we had the first derivative test, and now we have the second derivative test. So this is also going to tell us whether a critical point is a local max or a local min. So the condition that we need is that the second derivative is continuous near C. Then there are 3 possibilities. So the first is that, so we actually always need that this is a critical point, and it happens to be the type of critical point where the derivative at that point is equal to 0. So the other type of critical point is where the derivative does not exist, and then we can't use this test. So if it's the first type of critical point, then we can use the second derivative test. And what it says is that if we have that the second derivative is greater than 0, then we get a local min. Local minimum if we have that the derivative is 0 and the second derivative at C is less than 0, then we get a, then we get a local max. I should probably say at C, so at that particular point. And then the third case is if the second derivative is equal to 0, so f prime, so the first derivative is equal to 0 there, and the second derivative is equal to 0. And what happens when this is true, this means the test fails. So what we mean by that is that this test doesn't tell us anything about whether this is a, well, not that in particular, but at C, whether the point C is the location of a min or a max. So it could be that it is not a max or a min. It could be that it actually is, but we just can't tell. So basically it doesn't give us any information. So this is important. The second derivative test can fail. And so that is something to keep in mind. The first derivative test will always work. The second derivative test might not work in some cases. So we'll have a case where it does not work, and we'll see what we do then. Okay, so let's go ahead and do an example. But first I wanted to say, so to help myself remember the second derivative test, I like to picture this. So in the first case, if we're focusing on the first case, if the second derivative is greater than 0, that means that the function is concave up at that point, right? So if that happens, we get something that looks like a U, right? And then it says we get a local min at C, which makes sense because it would be like the bottom of that U, right? And then if the second derivative is less than 0, we get concave down. I don't really have space to put this in here, so I'm going to put it over here. We get something shaped like this, and so you can see that we get a local max when this is concave down, right? So I think it's helpful to draw a little example just to see whether it's whether it looks like it's a min or a max, and that will help you keep these straight. Okay, so now let's do the example. So when we have the, we're just asked to use the second derivative test to find the local extrema. And we're just given the function, so we have to find the critical points first, and then we will test the second derivative at each of the critical points. So first we find the first derivative. That will be 3x squared. If I bring that 2 down, it will cancel with the 2 in the denominator, so this will just be 3x minus 18. Okay, and so then we should go ahead and factor this. Probably don't need to do that. So I can factor out a 3 first. I get minus x minus 6, and then this is going to be, we can factor this into minus 3 plus 2. Yep. And so our critical points are going to be these two roots, or critical numbers, and those will be 3 and negative 2, right? Okay, so next we want to find the second derivative. So instead of using the factored form, which would mean I would have to use the product rule, I'm going to use the first formula that we had before we factored it, because that will be a lot easier to take the derivative of. So just applying the power rule, we would have 6x minus 3, right? And then all we need to do is take this, our second derivative, and plug in our two critical points and see whether the second derivative is positive or negative. So, or 0, because that could happen as well. So if we plug in 3, we'll get 6 times 3 minus 3, and that will give us 18 minus 3, which is 15. So that's greater than 0. And so the second derivative test says that now we know that we get a local, greater than 0. That means we get a local min at x equals 3. So that's the first one, and then we can also plug in negative 2, and we get negative 12 minus 3 equals negative 15, and that's of course less than 0. So the second derivative test says that we get a local max at x equals negative 2. So those are going to be our two answers. We get a local min at 3, local max at negative 2. So if this does work out, it actually is pretty nice to use. It's not too difficult, but do be careful. You see, I almost made a mistake here characterizing this one. So like I said, it helps to draw a little picture. So if you plug in your point, you get that this is greater than 0. That means concave up. And so you're going to get a local min because it's going to be the bottom of that U. And then if it's concave down, of course you get a downward facing U, and so you get a local max at the top there. Okay, so we will do the next example in the next video.